and thank you very much for inviting me to this conference, which I've thoroughly enjoyed so far. So yes, eventually I'm going to be talking about assessing potential climatic drivers of human behavioural evolution on the South African coast, but I'm going to get there via a description of the Sapiens Centre of Excellence, which is one of my two affiliations here, and also via a bit of a rant about chronology, because I'm a chronologist, so that's what I'm going to do. My other home is the Department of Geography in Royal Holloway, so University of London. That's where I spend most of my time. So, what is the Sapiens Centre of Excellence? Essentially, it's fairly obvious from emerging and actually quite a long-standing archaeological tradition that the southern African coastline between about 50,000 years ago and about 120,000 years ago was a fairly fundamental period for human behavioural development. There's a whole range of interesting things going on in the archaeology over that time frame. And here, if we just look at some of the early evidence that we have for the use of symbols, so symbolically mediated behaviour and advanced technology that come from just two of the sites that we're excavating as part of Sapiens, I hope you'll see the point that I'm making. So if I pick out some of my favourites, here at 100,000 years ago, we have the earliest evidence for the use of paint in the archaeological record. This is an abalone shell. It's a kind of fist-sized marine mollusk shell, and it was found hidden away in a corner of Blombos Cave, and it was full of powdered red ochre, which had been mixed with some kind of liquid to turn it into a slurry, to turn it into a paint. But interestingly, it had been put away very deliberately as a paint set. So in this abalone shell was also found a grinder, a piece of stone for grinding up the red ochre, so for making the powder to make the paint. And it was also found with a small seal scapula, which had clearly been used as a paintbrush. So here we've got a whole set, a whole kit of parts that allowed these people to paint things red with this ochre paint. At 70,000 years ago, again from Blombos Cave, we've got this engraved piece of ochre, and this is historically quite important because it kind of turned on its head our view of symbolically mediated behaviour in the human record, art in the human record. So this was published in 2002, and essentially it demonstrated that, contrary to previous beliefs, art didn't grow up, didn't evolve in Europe about 40,000 years ago. It was clearly part of the archaeological record 70,000 years ago in Africa. Contemporaneous with that, we've got these lovely shell beads. Various things happen over time. Sometimes they're strung together in pairs, as we see here. Sometimes they're strung singly. So you've got a change in fashion in the archaeological record. And all of this stuff, or sorry, the younger part of this material, so the 70,000-year-old part of this material, is associated with these wonderful heat-treated, pressure-flaked stone points, referred to as still bay points. If you go a bit younger than that, we've got, again, more symbolically mediated culture. We've got engraved ostrich eggshell found at a couple of sites, and you've also got the use of tools or points for projectile weapons. So there's clearly something interesting going on in the South African record at this time. And the point of Sapiens was essentially to explore the nature of that record, to try and understand what this archaeology looks like, to kind of dig down into the detail of what's going on in this archaeology, and maybe to try and start to answer questions about where, when, and why early humans, people doing this are us, this is Homo sapiens, why early humans started to think and behave in a recognisably modern manner like we do today. And amongst those questions, we need to answer a number of things. So, for example, what cognitive skills did we require? What cognitive skills need to be in place to develop more advanced technologies, and the social complexity that appears to be indicated by these uses of symbols? And we also want to know something about how adaptable humans were to environmental and climatic change, and whether those environmental and climatic changes acted as drivers for technological innovation. And really the motivation behind Sapiens is lots of people had been trying to answer these questions already. But when people used paleoclimatic data to try and explain the archaeology or cognitive explanations for the archaeology, very often those explanations lacked a meaningful understanding of the archaeological record, and vice versa. Archaeologists were perfectly capable of doing the opposite. And what we wanted to do was to get people together within a single centre and try and answer these types of questions with all the different specialisms talking to each other, integrating their data, and hopefully coming up with explanations that made sense in that context. So this really is just a description of what Sapience looks like conceptually. We are definitely an archaeological project. There's a lot of archaeological excavation going on within Sapience. But we are also generating primary climate data, climate models, but also proxy data. And we're also trying to think about the cognitive processes that might be associated with these changes in behaviour. So at the core of the project, we have the excavation of 3 Middle Stone Age sites in southern Africa, actually on the south coast of South Africa. Klipdrift Shelter, which is dated to between about 65 and 55,000 years ago. Blombos Cave, whose sequence runs from about 100,000 years up to 70,000 years. And Classius River, with a sequence running from about 120 up to maybe 55, 60,000 years ago. And we have 3 major components to the project. We've got a core archaeological component doing all the things that you would expect to go alongside archaeological excavations. So there's excavation, there's lithic analysis, there's faunal analysis, there is geoarchaeology, geochronology, and people trying to understand the landscape around the caves. We have a climate component, essentially centred on climate modelling, climate reconstruction from ocean cores and speleothems, and also climate reconstruction from material found within the archaeological sites themselves. And then we have the cognition component here, who are these days primarily interested in things like the transmission of information from one generation to another, the fidelity of the transmission of information from one generation to another, and what that tells us about our ability to do cumulative culture, but also risk perception associated with certain types of human behaviour. So that's what's going on within Sapience. Where do I fit within this? Well, people who are at this conference, they're highlighted by a red box. Where do I fit within this? Well, I'm a chronologist. I work out how old things are. Principally, at the moment, I work out how old archaeological sites are. And I do that using a technique called luminescence dating. And basically, luminescence dating is a technique that allows us to understand how long it is since a mineral grain was last exposed to sunlight. The fundamental premise here is that when a mineral grain is buried within a sand dune or within an archaeological site or whatever, it's no longer exposed to sunlight, and it begins to store up a record of the energy of the environmental radiation that it's been exposed to during the time that it's been buried. And that record is a accumulation of trapped electrons. Essentially, ionizing radiation removes electrons from their initial location within the mineral grain and causes them to be trapped at stable sites within that mineral grain. If we then expose our mineral grain to sunlight again, so the sediment gets eroded and the sand grains move around the landscape again, they're exposed to sunlight, and that sunlight gives the electrons just enough energy to escape from their trapping location, go back where they came from within the mineral grain, and that resets our luminescence signal back to 0. So fundamentally, what we are doing is we're looking at accumulated, effectively damage associated with exposure to environmental radiation during burial. So it allows us to work out the last time a mineral grain was exposed to sunlight. We've seen lots of complicated equations in this conference so far. I like to keep mine really, really simple. A luminescence age is the absorbed dose, the total amount of radiation the mineral grain was exposed to during the burial period, divided by the environmental dose rate, the rate at which that mineral grain is being exposed to radiation. So it's really simple. It's amount of change divided by rate of change. We calculate the absorbed dose using luminescence measurements, and we calculate the environmental dose rate either by directly measuring the radioactivity of the sediment that we are looking at using something akin to a Geiger counter, or we can measure the radioisotopes within the sediment, the naturally occurring radioisotopes within the sediment, and infer the environmental dose rate from that. So, within the Middle Stone Age of Southern Africa, in the time period between about 120 and 50,000 years ago, there are two really charismatic techno-complexes. They are the Still Bay and the Howson's Port. They're very distinctive, so Still Bay points are the fossil associated with the Still Bay. Howson's Port is associated with these projectile tips. They tend to suck some of the life out of other time periods in the Middle Stone Age because of this kind of charismatic nature, because they are very, very distinctive. They are also, if not quite ubiquitous, then common. Pretty much all the way along the coastline from Namibia, all the way around the South African coastline up towards Mozambique, you have sites that have these industries. And they received a lot of attention. Not least of which was attention from chronologists. So in 2008, Zenobia Jacobs dated 54 single-grain luminescent samples from Still Bay and Howson's Port sites. And she said, if you do that, actually we find that those two industries fit within very tightly defined timeframes. The Still Bay between 72 and 71,000 years before present, the Howson's Port between 65 and 59,000 years before present, and there's a bit of a gap in between the two of them. Those are all luminescence dates. And that was a very interesting story, but quite quickly people started to dig holes in it. So we've got two components to an age equation, the absorbed dose divided by the environmental dose rate. So if we deal with the environmental dose rate first, this paper here, published in 2013 by Guillaume Gorin, suggested that actually the way that the dose rate had been calculated for some, but not all of the samples within this study was incorrect. Now, there's a fair amount of angst and animosity around this particular claim, but the long and short of it is actually pretty much everyone agrees that although they disagree on how you calculate the dose rate correctly for some of these samples, it doesn't make a great deal of difference. So that problem very nicely went away. The other one didn't, and that's a problem, and it's the problem I'm going to talk about for the next few minutes. So, two different people, Chantal Tribouleau and Zenobia Jacobs, both dated the same sequence at Deep Kloof rock shelter. Now this is a sequence that goes all the way from pre-Still Bay, stuff below Still Bay, through Howson's Port, and then into stuff that's younger than the Howson's Port. But you'll see here that we've got two completely different chronologies for this single sequence. So the black symbols here, those are Zenobia Jacobs' dates, and the white symbols here are Chantal Tribouleau's. Very, very different. If we look at the Still Bay, Tribouleau says the Still Bay is about 110,000 years before present. Jacobs says it's about 70,000 years before present. That's the bit that's highlighted here. Similar problems with the Howson's Port. Chantal Tribouleau has it running from about 110,000 years before present through to 50,000 years before present, and the Jacobs chronology, again, much, much shorter, much more tightly constrained, 65 to 59,000 years before present. So why is this happening? Well, one of the things that you've got to do when you make luminescence measurements is you've got to pre-treat the sample. It's kind of analogous to what Tom was talking about with radiocarbon dating. Essentially, there's a series of steps that you've got to do before you actually measure the luminescence from your sample. And Chantal did a really nice set of measurements, and she demonstrated that some of the samples appeared to be relatively sensitive to measurement conditions, and if you got those wrong, then you could potentially get the ages wrong as well. So essentially, Chantal Tribouleau suggested the discrepancy between these two chronologies relates to pre-treatment of the luminescence samples. After a lot of work, Zenobia Jacobs and Bert Roberts demonstrated it wasn't. That actually the samples that they'd worked on were relatively insensitive to these changes in preheating conditions, or sorry, pre-treatment conditions, and therefore that wasn't the problem. What was the problem? Well, they suggested it boiled down to dose rate again. They noticed that where their samples differed in age from Tribouleau et al.'s ages, the difference between the two sets of measurements was the dose rate, and most of the difference was attributable to the potassium concentration of the samples. Essentially, O had much lower potassium concentrations in some, but not all samples, than Zenobia-Jacobs had. That gives you a lower dose rate, and obviously, if you're dividing the same absorbed dose by a lower dose rate, you get a larger age. So potentially that explained the discrepancy. Now, under normal circumstances, this would just be an irritating but small chronological quirk. But actually, this situation is pretty much where the field stood at the start of Sapiens. And that was a problem, because if you don't know whether the house and sport starts at 110,000 years ago or 65,000 years ago, you're going to have real problems coming up with explanations for what's going on within the house and sport, because you've got no idea what the climatic background to this particular industry is. And so we ended up with two mutually exclusive interpretations of the archaeological record. One, based on this much longer chronology for the Still Bay and the house and sport proposed by Chantal Triboulet, and one based on a much shorter chronology from this Jacobs et al. Series of studies. Now clearly, if Sapiens is going to do its job, as an absolute minimum, we need to have robust age controls for our own sites, because we can't even begin to assess potential climatic drivers of what's going on in the archaeological record if we don't know how old our own archaeology is. So the obvious thing to do, from our perspective, was to use a range of different techniques to look, a range of different chronological techniques to look at the sites that we were excavating and the sites that we're involved in, and try and understand the chronology like that. First thing we did was to look at cryptotephra. Mike and actually Tom have already talked about this a little bit, but essentially when you've got large volcanic eruptions, they erupt a large amount of volcanic ash into the atmosphere, and then that gets distributed mostly downwind of the eruption, and it can form an isochron. It can form a single age level across a whole range of climatic sequences and archaeological sequences, and it allows you to understand when a particular point in time happens. Mike talked about the youngest Tabor tuff, the YTT, the Tabor ash, which results from an eruption in Sumatra 74,000 years ago. It's a big eruption, and all of these white dots here are sites where the Tabor ash has been found. Now, 74,000 years ago, that's immediately prior to when the Still Bay should be, if you are subscribing to the Jacobs et al. Model for when the Still Bay should be, which is 72,000 years before present. Although Southern Africa is a long way away from Sumatra, there has been Tabor ash found in Lake Malawi, and there's also been Tabor ash found in a Middle Stone Age site just down the coast from Blombos called Pinnacle Point 5-6. And that was published by Smith et al. In Nature in 2018. And nicely, it sits just below the Still Bay. So here we have a Bayesian age depth model for the Pinnacle Point site. All of these are single grain luminescence ages. We've got the Tabor ash at 74 Ka just before the Still Bay. House and Sport and Still Bay dating sit very neatly within the time frame that you might expect based on the Jacobs model. Okay, so that's good. We know how old the Still Bay and House and Sport are at this one site, Pinnacle Point. So we tried to do the same thing at Blombos, and we took a sequence of tephra samples from Blombos in 2019. Now these aren't my data, so please don't show this slide, but Sunniva worked on these samples really intensively, and she found 29 shards of ash immediately beneath the Still Bay at Blombos Cave, and 25 of those shards form a really neat, really tight cluster geochemically, which is exactly what you want if you're going to do tephrochronology on a site. So we were really excited about this, looked at the results, compared it with the Tabor ash, and it's not the same stuff, which is unfortunate. So here we have a number of different distal occurrences of the Tabor ash, Jodhapuram, Lake Malawi, Pinnacle Point. Nice cluster, they all sit on top of each other according to a variety of different chemical ratios, and the Blombos data is very clearly different. We don't know what that tephra is yet, but it's clearly not Toba. So unfortunately, we can't put a second age to the still bay at Blombos Cave using tephra chronology. Now this is the only one of the sapient sites that has the still bay, so it's the only one where you would expect to find the Toba ash, so we needed to move on to another technique. Now, any chronologist has uranium series envy. So the next thing that we did, obviously, was uranium series dating. Now, Middle Stone Age sites in southern Africa are absolutely full of ostrich eggshell. Lots and lots of ostrich eggshell in all of these sites. And in principle, you can date them using uranium series, but conventional uranium series methods have not historically worked well on ostrich eggshell, because essentially ostrich eggshell takes up uranium over time from the surrounding environment, so it utterly violates the idea of a closed system. However, Warren Sharp at the Berkeley Geochronology Center came up with a method for exploiting the structure of ostrich eggshells to produce decent uranium series ages from them. Essentially, the point that they made in this paper in 2019 was that there are 3 layers to an ostrich eggshell. You've got the outside vertical crystal layer, basically a dirty layer on the outside of the shell. You've got the inside mammillary cone layer, which has negligible uranium. And then you've got between those two the palisade layer. Now the interesting thing here is the inside layer of the shell has no uranium in it. Essentially it is impervious to uranium. And because of that, we know that any uranium that's coming into the shell is coming in from the outside, not from the inside. So we've got a predictable direction of movement of uranium into the shell, which allows you to model changes over time. So what Warren and his colleagues did was they took away the bits they weren't interested in, so the outside and the inside of the shell, and just had this palisade layer, which is the layer in which you've got predictable uranium movement. They then divided that layer into 2 separate tablets with known depths within the shell. Uranium series dated both of these tablets, so they produced 2 uranium series ages from a single shell, and then they extrapolate that age to the outside of the palisade layer. Now what that's doing is it's giving you an age for the first point of arrival of uranium into the outside of the shell. Or to put it another way, it's telling you the point at which the shell was buried in the sediment, which is exactly the same thing as luminescence ages are doing. So we've got a comparable event that we're trying to date here. So, Warren Sharp and his then PhD student, Elizabeth Nice-Polo, went to Vache Rivière 003, a site on the west coast, a site that I was also working on doing luminescence dating. They did uranium series dating, I did luminescence dating on the pre-still bay levels from Vache Rivière. So I should just go back a step. Vache Rivière has pre-still bay levels, so stuff that predates still bay, Howson's Port, and a little bit of stuff that's slightly younger. So when we worked on the pre-still bay layers, 4 luminescence ages, 3 uranium series ages, we get an age between 92 and 80,000 years before present. Kind of where you would expect it to be. The still bay lies on top of this and therefore must be younger. We have one outlier in the uranium series data, possibly an ostrich eggshell that's slightly out of context, but basically there's a coherent story here. The still bay wasn't directly dated, but I did luminescence dating on the Howson's Port, and we get ages between 72, 55,000 years before present. Again, pretty much where you'd expect it to be according to the Jacobs model. We did the same thing at Clipdrift Shelter. So Clipdrift Shelter is a site that was first published in 2014. I produced a series of luminescence ages dating the Howson's Port to between about 65 and 59,000 years before present. It's not a particularly tidy data set. These ages are in stratigraphic order, but it's pretty consistent with what we think we know of the age of the Howson's Port. Again, not my data, please don't show this slide, but if you compare my luminescence ages in green with the uranium series ages on ostrich eggshell in blue, they pretty much agree with each other. Here I've ordered the samples by depth, so they're equally spaced by named horizon as opposed to sample depth. But essentially, old at the bottom, young at the top, Howson's Port in the middle, 68 to 55,000 years before present. Let's come back to Blombos, the site that we started out with. Actually, although we couldn't get any tephra ages from this site, it's a pretty well dated site. So there's a small issue of 40 luminescence ages combined in a really nice Bayesian age depth model published in 2020 by Zenobia Jacobs, and it dates the end of the still bay to 71,000 years ago, when she would expect it to be. I've completely redated the site using new samples, different lab, everything's different, so it's completely independent luminescence dating of the site. And what we see here are Zenobia's ages for a particular layer and then my age for a particular layer. Essentially, all I'm plotting here is situations where I have an exactly equivalent date from one of Zenobia Jacobs's. And again, we see maybe my data are a bit more scattered, but it's telling exactly the same story. And also, the chief protagonists in this whole sorry story of chronology have also dated Blombos Cave, and they agree that the still bay the still bay occurs at about 71,000 years ago. So, we know the age of the still bay at Blombos. So let's have a quick recap. Where are we? At Vache Riviere, the still bay is less than 80,000, and the Howson's-Port sits exactly where you'd expect it to on the basis of the Jacobs et al. Chronology, and that's luminescence and uranium series dating techniques. Same thing at Klipdrift. We've got a Howson's-Port that dates from 65 to 55,000 years ago. At Blombos, we've got the end of the still bay at 71,000 years ago, and at Pinnacle Point, using luminescence and tephra, the still bay is less than 74, the Howson's-Port 67 to 58,000 years ago. And then we've got Deep Kloof, this site here, which sits between Vache Riviere and Klipdrift, Blombos and Pinnacle Point, where we've got two chronologies. It should be stated at this point, there is absolutely no reason, based exclusively on the luminescence data from Deep Kloof, for supporting one age model over the other. But I would argue quite strongly, based on all the information that we have elsewhere, that it's clear that this is the easiest chronology to explain, and this one is really difficult to defend. So for the purposes of what I say next, I'm going to remove that. I am pretty certain that the Jacobs et al. Chronology for Deep Kloof is right. So, we now know how old the still bay and the Howson's-Port are. There's an interesting thing about the still bay and the Howson's-Port, and that is that they are fairly consistent. You've got pretty much the same thing going on at each still bay site. Still bay looks the same at each still bay site. Howson's-Port looks the same at each Howson's-Port site. And we've got very similar still bay and Howson's-Port all the way from Apollo 11 up in Namibia, all the way around the South African coast up to Cebudu towards the Mozambique border. So these populations are clearly talking to each other. They're clearly connected. There is a connection between these people at this time. So between 72 and 58,000 years before present. But that hasn't always been true. So I've already talked to you a little bit about Vache Riviere, and I've cited this paper written by Alex Mackay, published by Alex Mackay in 2022. And there I was talking about the chronology for the still bay and the Howson's-Port. But that wasn't the point of the paper. What Alex wanted to do was to explore the nature of the archaeological record at this site. And the point that he made is that when you've got still bay and Howson's-Port at Vache Riviere, it looks like still bay and Howson's-Port everywhere else. But the stuff immediately beneath the still bay, so older than the still bay, the stuff that Elizabeth Nispolo and I dated to 92 to 80,000 years ago, is very different from what we see elsewhere in the Middle Stone Age record of Southern Africa. It's also very different from the overlying still bay. It's not something that kind of necessarily leads into it. I'm beginning to run out of time, so I don't particularly want to labour the differences, but essentially you've got flaked ostrich eggshell, which appears to be the result of people puncturing ostrich eggshells to use them as flasks for carrying water. You do see flasks elsewhere in the Middle Stone Age record, but there they're grounding the aperture as opposed to puncturing it. The 92 to 80,000 year old material at Vache Riviere is focused on Silk Creek procurement. Elsewhere, contemporaneous sites are pretty much looking at local, producing their tools on local quartzite and hornfels. We've got really intense heat shatter to produce core blanks to begin to produce tools at Vache Rivière at this time period. Elsewhere, heat shatter is pretty rare in contemporaneous sites. And you've got this slightly odd thing, which is Vache Rivière is not next to the coast. It's about 50 kilometres away from the coast, and yet there are a small number of marine mollusk shells in there. Clearly, people are bringing marine mollusk shells to the site for a reason, and that reason is unlikely to be food, because frankly, I wouldn't eat a mollusk after it had been transported 50 kilometres from the coast. You see exactly the same thing in Namibian sites further north, which are even further away from the coast. Admittedly, the Middle Stone Age along the southern part of the South African coast is absolutely full of shellfish, but there it's clearly opportunistic use of shellfish for foodstuffs. Here, at Vache Rivière, between 92 and 80,000 years ago, something else is going on. This isn't principally use of marine shells for foodstuff. They're taking it there for a reason. We don't know what that is, but it's not to eat. Well, it's probably not to eat. And interestingly, as soon as you get into the Still Bay and Howson's Port, they stop doing this at Vache Rivière. So, we've got archaeology that's noticeably different from what's going on in nearby sites. And between 92 and 80,000 years ago, but very, very similar to what's going on in nearby sites subsequently. How do we explain that? Well, if you look at the phytoliths from this site, you see a very strong difference between the pre-Still Bay levels and the Still Bay and Howson's Port levels. So if we look at 65,000 years ago, so that's Howson's Port, that's when we think all these sites are connected together. We have strong winter rainfall dominance evident from the phytoliths, and Vache Rivière is currently in the winter rainfall zone, so that's not particularly unexpected. So the evidence there is that we have more cold season growing grass phytoliths, and we have a high proportion of restios which are very strongly linked with winter rainfall in the Cape. On the other hand, if you look at the stuff that's prior to the Still Bay, the stuff that's very different from what we see elsewhere in nearby sites, then there, at 85,000 years ago, winter rainfall is dramatically reduced, and we've got much stronger relative importance of summer rainfall. But critically, overall, this site seems to be quite a lot drier at that point. And the Mackay et al. Paper comes up with a potential answer to why this is happening, but clearly the pattern is there, that we can see the pattern in the phytoliths. We can test this explanation, hopefully in the future, using Ozan's downscaled model results. And essentially the hypothesis that we come up with here is that when we have weaker winter rainfall, stronger summer rainfall, but overall a drier site, Vache Rivière here is disconnected from the South Coast sites, and they're busy doing their own thing. They're generating their own material culture. They're generating their own archaeological traditions. And we can see potentially there's some links up to Pockenbank and Apollo 11 up here in Namibia. Those are the other sites where we see movement of marine mollusks to non-coastal sites for some reason other than eating. However, once we get strong winter rainfall dominance at this site, then the archaeology here looks pretty much like the archaeology all the way around the coast. These populations are linked together again. So clearly there we can see evidence that the changing regional patterns of climate are influencing the type of archaeology and the way that archaeological populations are interacting with each other. And so, to conclude, like any good undergraduate essay, therefore it can be seen that chronology is vitally important for assessing potential climatic drivers of human behavioural evolution in the archaeological record of the southern African coast. Thank you very much.